Okay, so sometimes when we find areas, the area might actually end up being below the x-axis. So in that case, your integral is going to end up being a negative answer. So it's okay that definite integrals end up being negative. That definitely could happen, but in terms of areas, we want to state it as a positive value. So in the end, in our last step, what we have to do is take the absolute value to find that positive area. So here's a question where this may happen. So find the area of y is equal to x squared minus 16 between the roots of a function. So roots are the x-intercepts. So I'm going to find the x-intercepts first, and that occurs when y is equal to 0. Okay, so I'm going to find the roots. So when I bring 16 to the other side, I get positive 16 is equal to x squared, so therefore x is equal to plus or minus 4. So those are my roots. So I have one at negative 4 and the other one at positive 4. So it looks like it's symmetrical about the y-axis. And what's the y-intercept going to be? The y-intercept is when x is equal to 0. So 0 in this place will give a y-intercept of negative 16. So obviously not really drawn a scale, but what we should expect here is a parabola that opens up because your a value is 1. And so I'm just going to nicely try to draw a nice graph here. And okay, that's good enough. So here's my parabola. We want to find the area between the curve and the x-axis between the roots. So we want to find out what this region is. Okay, so trying to find this region, we have to define the actual integral that defines this region. So that's my second step. So my integral, my area, is going to go from my lower limit of negative 4 to my upper limit of positive 4 for my original graph, which is x squared minus 16. So x squared minus 16 is what we consider my integrand, and there's my integral that represents the area. So once again, it's going to be negative, but in the end, I have to make it positive by taking the absolute value of this function. So before I do that, I'll go ahead and take the antiderivative. So I get x cubed divided by 3 minus 16x. Okay, and then we're evaluating from negative 4 to positive 4, and then I'm going to substitute my values. So I always start with my upper limit. So I get 4 cubed divided by 3 minus 16 times 4, and then I'm going to subtract my lower limit evaluation. So I'm going to go negative 4 cubed divided by 3 minus 16 times negative 4. Okay, and we'll close that bracket. So I just have to be really careful because I'm subtracting all of this. So I'm going to evaluate now. So 64 over 3 is what I get for this simplified, and then 16 times 4 gives me 64 again. Then I'm going to subtract. In the brackets, negative 4 cubed actually gives us negative 64 over 3, and then negative 16 times negative 4 gives us positive 64. Okay, so just to get rid of the square brackets here, I get 64 over 3 minus 64, and then a minus and negative gives me positive 64 over 3. And then minus a positive 64 gives you minus 64. So when we bring this all together, I'm going to bring my fractions together. I'm just going to add the tops. So I get 128 over 3, and then negative 64 minus 64 is going to give us negative 128. So in the end, I'm going to actually get a negative fraction. I'm going to get negative 256 divided by 3. So therefore, my area is equal to the absolute value of negative 256 divided by 3, which is going to give me just 256 divided by 3. So that right there is my area. So if it's underneath the x-axis, all you need to do is find the area of that negative area, and then make it positive by taking the absolute value.